Hello, once again, we are in pre-calculus and we're going to be talking about Unit 3 today, which is symmetry, which is just the nature of graphs, but we're going to be talking about specifically symmetry and coordinate graphs. Okay, so real fast, let's go ahead and take a look at, not GeoGebra, but our Desmos. Dun dun dun. Okay, so symmetry. There's a couple of things about symmetry. Honestly, you can cheat and look at your graph and just go, oh, is that symmetrical with the y-axis or x-axis, or y equals x line or y equals negative x line. It's up to you how you want to do that. I think the best way to do it also to do it is analytically, which is, do it by doing the actual algebra. Okay, so let's just take our typical one. Let's look at the graphically. Okay, this is symmetrical with the y-axis. Okay, this one would be symmetrical with the x-axis. So those ones are pretty simple. Okay, y equals x to the third. Okay, now this one right here, this is symmetrical with respect. It's called point symmetry. If I were to rotate this upside down 180 degrees, this graph would still be, here, let me make it darker so you can see it. This graph would still be the same. So if I rotated it 180 degrees, I still have it. Or rotated it any kind. Like for example, this one, x squared plus y squared equals 1. Okay, so for example, this would have rotational symmetry, so therefore this also has point symmetry about it. So that's kind of nice to know. Alright, now something that actually had respect to, let me see an example of a graph. Something that had respect, a type of symmetry with respect to the y equals x line, which would be this one, xy equals 6, something that looks like this. Okay. And how could you test it? You could actually go y equals x, and you can see the symmetry as you zoom out. It's like, oh, that's really nice. That really looks like a good picture of it. Okay. Now this one is more typically written as y equals 6 divided by x. So it's a rational function. Okay. Now obviously a negative rational function would have respect to the y equals negative x axis. So that's another one that looks like that one. Alright, now some really complex conics that you are going to see that also have respect to the y equals negative x line. Here's one. Let me type it in for you. 17x squared plus 16xy plus 17y squared equals 225. Okay, something looks like this. This is a conic. This is an ellipse with rotational of about 45 degrees clockwise rotation, or negative 45 degrees counterclockwise if you have the major axis going along here. Right, but as you can see, it definitely has the symmetry right there. It splits it right in half. It's a mirror image on either side. So both of them actually work out pretty well, so that's kind of nice. Okay, now the major thing that I did want to talk about was analytically how to solve this stuff. So analytically, okay, alright, so we need to have some stuff set up. Okay, and this is how you tell the certain types of symmetry, and I'll talk about even or odd in a sec. Okay, so y-axis, x-axis, y equals x symmetry, y equals negative x. Oh, and I do need to have, I forgot about it, let's say origin. Symmetry. So y-axis symmetry, plugging in, I believe it's a comma negative b doesn't change the function. So in other words, if I took x and y and I plugged in a and negative b in those respective spots and I worked it all out and I still had the same function as I did before when I just plugged in a and b. So first off, I'm sorry, I should have said that in the beginning. You have to plug in a and b into your function. Now if you plug in a and negative b and the function's the same, then you have y-axis symmetry. If it's not, you do not have y-axis symmetry. Okay? So alright, now the same thing is going to be pretty much said for x-axis symmetry, but instead of a negative b, it's going to be negative a comma b. And once again, you have to plug in a and b into your function. And then you plug in negative a and b, and it doesn't change the function. So that's x-axis symmetry. Let me double check. Yep. Okay, so on this one, you plug in a and b. And right here, instead of plugging in a and negative b, you would plug in b and a. And if you could plug in b and a and still have the same function as you did before, then you have y equals x symmetry. Okay, this one right here, once again, you still plug in a and b. Okay, but instead of plugging in b and a, you plug in negative b comma negative a. And if you do that and it doesn't change the function, you have y equals negative x symmetry. Okay, so let me see. All right, now origin symmetry, and I'm just going to say this. You do the same thing. Okay, but instead of plugging in a and negative b, you plug in negative a and negative b, and it doesn't change the function. And once again, you still need to use the a comma b. Okay? Alright, now, when looking at this stuff, you're probably sitting there going, okay, that's great and everything. How do I tell an even and odd function? Okay, I'm going to tell you right now. Even functions have y-axis symmetry. Odd functions have origin symmetry. And once you have that, you're all set, because the x-axis, y equals x and y equals negative x, doesn't help you with the even or odd functions, but it does help you identify the type of symmetry you're going to be dealing with. Okay? Alright, so once again, you just plug it in, you just see it. So let's take a typical one. Let's take a look. Oops, let's change the color back to black, because that would just be crazy. Alright, so let's say we had f of x equals x to the fifth. Okay, so I just plug in a and b, so I get b equals a to the fifth. Okay, so I plug in a and b. Alright, so first off I'm going to test a comma negative b. Okay, and this is going to test, I believe, yes, y-axis symmetry. Okay, alright, so I plug it in, I get negative b equals negative a to the fifth. And you do have to put the parentheses around it because you are raising it to a power. Okay, and I get negative b equals negative a to the fifth, because raising it to the fifth power. Now if you notice, these are not the same. Okay, so these are not the same, so this is no. It does not have y-axis symmetry. Now if I plug it in, negative a comma negative b, if we just check out that other one, okay, if I plug in both of those, oh geez, what am I doing? I accidentally tested out this one first, so let's move this one down here. Okay, let's get rid of that. I accidentally tested out the origin symmetry first. Okay, now the origin symmetry, I always make this mistake when I have it. Okay, plugging in negative A and negative B does make the opposite function. Okay, alright, and that one is going to have to be better explained in a second. Okay, so we plug in everything. If you notice, everything's opposite than it was before. Okay. So origin. Okay, since everything's opposite, and that's a little bit different, this one actually has origin symmetry. Okay, now if I go back to here, and I plug in negative B and negative A, or negative A, or sorry, negative B and positive A, I don't get the same thing. Then if you notice I don't get the same thing as I did before, then this would be a no. Okay? Now what if I plugged in B comma A, and I have to get the same function? And if you notice, I'm probably not going to get the same thing. Alright, so in other words, I go through again. A equals B to the fifth. That's a big no, because that's not the same as it was before. And I bet you can guess that if I plug in negative B comma negative A, this is just not going to be working as well. Okay, so in other words, you're just plugging in. Now, what does this also mean that this function is? This means that this function is odd. Why? Because it has the origin symmetry. Okay, if what I plugged in was the exact opposite of what I wanted. Okay, and that is true. It does work that way. Now, a simpler way to actually do that, and I like to test this out too, is the even and odd functions. Is even functions, if I plug in, if I take my function and plug in negative x, and I get out the function without the negative anymore, in other words, it doesn't change anything, then that means it's even. I like to think of it that way. Right, now if I take my function and I plug in a negative, but I get out the opposite of the function, okay, then I like to think of that as odd. So that's a helpful reminder for it, okay? Alright, thank you guys very much. Have a great day. That's symmetry and even and odd functions.